All chargers require periodic inspection and adjustment. Proper maintenance will prolong the useful life of a charger and the battery that it serves. This last part of the program will demonstrate some basic battery charger inspection and adjustment tasks. The key points that will be covered include inspecting general charger conditions, checking for AC current and AC voltage output from the charger, checking float and equalizing voltages, and checking the calibration of the charger's voltmeter. Routine charger inspections and adjustments are typically done while the charger remains in service, so internal terminals will be energized. As usual, all required safety precautions should be observed. In general, charger inspection and adjustment steps can be done in any sequence. A good place to begin is to check the charger for signs of excessive heat. The outside of the charger can be felt to determine if the charger is too hot. Excessive heat may indicate faulty internal components, poor internal connections, or poor ventilation. Excessive heat can result in charger failure. To ensure good ventilation, the area around the charger should be kept clear so that nothing interferes with the free flow of air. In particular, the ventilation openings in the charger cabinet should be checked for obstructions. The interior of the charger is also checked for signs of heat, such as discolored terminals. Heating at the terminals is an indication of corroded or loose terminal connections. Any loose connection should be tightened. If necessary, the terminals would be cleaned using the appropriate tools and observing all other required safety precautions. A common cause of heat is dust buildup on surfaces designed to dissipate heat. Dust should be removed regularly. The internal components may be brushed, vacuumed, or blown clean. In addition to inspection and cleaning, the charger output voltage and current are noted and recorded. Any variation from the normal operating ranges should also be noted. On a periodic basis, it's a good practice to check for AC voltage at the battery. If a charger starts to go bad and loses its ability to convert AC to DC, it will show up at the battery. A meter, such as this digital volt-o-meter, can be used by setting it to measure AC voltage and placing the test probes across the terminals of the battery. The AC voltage reading here is within reason. If a charger is going bad, there will be a large AC voltage output from the charger, and the charger would need to be replaced. The float and equalized voltage settings should also be checked periodically. This can be done using a precision voltmeter or multimeter that's switched to a DC voltage setting. The voltage is checked with the charger in the float charge mode. In addition, the charger output current should be close to zero, indicating that the battery is not discharging. If necessary, the float voltage potentiometer is adjusted to provide the required float voltage output to the battery. The voltage is also checked with the charger in the equalizing charge mode. Again, if necessary, the equalizing voltage potentiometer is adjusted to provide the required equalizing voltage output to the battery. After the equalizing voltage output is checked, the float equalize switch is returned to the float charge mode. In addition, with the voltmeter still connected across the terminals of the battery, the calibration of the charger's panel voltmeter can be checked. If the panel voltmeter doesn't agree with the portable voltmeter, the panel meter is adjusted until it matches the reading on the portable voltmeter. This is done by turning a zero adjustment screw at the panel meter using a screwdriver. Finally, if the charger is equipped with alarms and protective relays, the operation of these devices may also be checked according to charger manufacturer instructions or company procedures. All checks and adjustments made to a battery charger should be accurately and thoroughly documented. These records serve as an invaluable tool for determining what additional attention a battery charger may need. Inspection, maintenance, and adjustment tasks, such as those shown in this part of the program, help to ensure that a charger provides the necessary DC power to the battery and to the other DC loads. A properly functioning charger is essential to ensuring reliable protection and control of transmission and distribution systems. Overall, this program presented basic charger functions and components, the layout and operation of a DC control system, common types of charges that may be applied to a battery, and charger inspection and adjustment tasks. In addition to the foundation provided by this unit on substation battery chargers, and for more complete training in substation battery systems, you may want to continue your training by learning about substation battery testing and by learning about substation battery, cell, and charger replacement.